Hey everyone, what? Yes, my eye's feeling better. I was sitting there listening to audiobooks yesterday, just keeping my eyes shut. Like I tried rinsing them out, I don't know what the fuck was wrong. Felt better after keeping the eyes shut all goddamn day. And then sleeping with like it just fucking so whatever it was irritating shit out of it. We're gonna go over 1.4 and 1.6. There is something I want to do first. Jimmy, I am sorry.
I don't give a damn.
No, I know you don't, but it's important now. Jimmy, I am sorry that I was implying that you were a chicken for not answering. That's fucked up. Teachers shouldn't do that. I do not feel bad about instigating, but I do feel bad about calling you a chicken because that's inappropriate. I don't want anyone to feel in here to feel like I'm judging you for not like raising your hand and giving answers. Okay? If you don't have to ever answer questions, you will thrive more if you participate more. Answer questions, even if you're wrong or right. Jimmy's fucking wrong all the time and still learns from it. There's nothing wrong with him. He's wrong a lot, but he's only wrong when he thinks he's right and then he's wrong to answer it. But there's nothing wrong with that. There's nothing. It's like awkward to answer when you think you're wrong. But there's nothing wrong with you do. Luis doesn't give a shit. He just fucking answers. Sometimes he's usually right, sometimes he's wrong.
Appreciate that, Paul.
So, everyone, there's that. I messaged Jimmy that night, and I knew he didn't give a shit, but I realized there's other people in the class. I don't think it was all that appropriate. I will keep instigating them. So, like, Luis keeps talking shit, I'm gonna keep fucking instigating. All right, since only Eric fucking followed the instructions, let's put that on the video also. Only Eric fucking listened to instructions.
I was gonna say, I think you should close that.
Yeah, let's leave that now. How many bitches come from? Ain't no one ever hear this lady. Also, there's a lot of other people. Right?
I've seen them.
Alright, so. I don't know what day class this is, 12, 13, fucking I don't know. I do know it's the 10th day of lecture. And we're gonna hit 1.4 and 1.6 today. 1.4 is on quadratic equations. What?
I don't think it's right on this.
You don't, if you want to, if you don't want to, you don't. He could, but there's a good chance I'm gonna say some shit differently. You might gather more out of it the second time. But if he wants to leave, no one has to be here.
That's true.
I ain't calling taking a roll. I love getting it, still get emails. Mr. Jones is gonna be absent today. Okay, thanks. If they tell me why, I'll give a compassionate response, but otherwise, I don't give a shit. If you're not here, you're not here. I got my education. That callousness is important. So, quadratic equations are in the form ax squared plus bx plus c equals 0. Where a, b, and c are real numbers. One side equaling 0 is vital. So if it doesn't, make it that way. So let's. I'm gonna start off with 8x² plus 5x or minus 5x equals 5x plus 3. This is different than the one Eric saw earlier because I just made up this equation right now. So it is not written in the correct form to use any of our things, so we're gonna write it in the correct one first. We'll subtract, we'll move everything over to where the x² is. And I get 8x² minus 10x minus 3 equals 0. This is gonna be our practice equation for a bunch of shit coming up right now. The first rule we want to look at is called zero product. Or it's got two names, zero product or zero factor. If A and B are complex numbers, with A times B equal to 0. Then either A equals 0 or B equals 0. Wish I hadn't used A and B there because I want to point out something with complex numbers. Complex numbers usually go by the letter Z. Z equals a real number plus an imaginary. So like smiley face plus frowny face times I. Where smiley face and frowny face are just numbers. If frowny face is 0, then Z is just a real number. And it's not really, we wouldn't bother calling it complex. So real numbers work here. When it says complex numbers, real numbers work as well. That was the point of that topic. So one way of doing this, we're gonna work on 8x² minus 10x minus 3. And we wanna factor this, so A times C is -24, B is -10. One of them's positive, one of them's negative. To get a multiple that's negative or a product that's negative. And the bigger one's gotta be negative to get a negative number there. So I could do 1 and -24. That adds -23, that's not it. 2 and -12. That adds up to -10, those are our factors. So I have 8x squared minus 12x plus 2x minus 3 equals 0. We do our grouping. You want to keep writing equals 0 here at this point. Because if you don't, you're gonna forget to do it on the test. And you're gonna lose points for it, and then you're probably gonna forget to solve, and you're gonna lose points for that. So if it has an equal sign, you should have an equal sign every step of the way. 2x minus 3 doesn't have anything in common. So I'm just gonna put a +1. I should have a 2x minus 3 on the first thing if I'm doing grouping. And to get that, I need a 4x. So all that factoring shit we worked on is still handy. So if I finish grouping, I have 4x plus 1 times 2x minus 3 equals 0. Okay, so to use the zero product rule. This is a number multiplied by a number. A times B equals 0. So I've got two things multiplied together that equal 0. I'm gonna set each of them individually equal to 0. Then we just solve each of these like normal. We've solved linear equations before. And 3 to both sides there. Divide by 2. I get x equals -1/4 or 3/2. Now, if you have the answers, you can actually work back and see what the equation was. Like if I wanted to work back to see what the equation was. On both of them, I'm gonna clear the fraction first. Here, I'll multiply by 4 on both sides. And here I'll multiply by 2 on both sides. And I get 4x equals -1. And 2x equals 3. Maybe he watched the video too.
Let's say he heard I'm gonna be.
Then I would add 1 to both sides. I'm working backwards. Here I'd subtract 3 from both sides. And now that I see these are equal to 0, I can grab them and throw them together. So you can work backwards. I don't know if any questions asked for that, but some of them, at some point, we're gonna do some stuff where this is a handy fucking ability. Definitely when we do finding the roots of rational equations. This is pretty straight, this is one of the easiest methods. Well, it's a lot easier when there's no like 8 in front of it. A lot easier when that's a 1. But that was too fucking easy. I have higher standards for you guys. You guys can do it.
Wait, so to work backwards, you use the number in front of the variable, right? Or the,
So I had x equals negative 1/4. I cleared the fractions
oh,
and then I got everything on one side.
okay,
And I did it for both of them. So I got everything on one side, which is kind of like this right here is right there.
okay,
And working backwards, we can multiply them and we still get 0. All right, so that's the 0 factor or the 0 product rule. I'm not gonna use the same equation for the next thing, because it's kind of handy to see. Next idea before we actually go on to do the more complicated shit. Does anyone need this up longer? Okay. So we can take advantage of the square root property. If I have x squared equals c. And I take the square root of both sides. Square root, square root. Square root of x squared is x, square root of c is plus or minus square root of c. This is gonna result in either 2 real numbers or 2 complex or infinite numbers. So for example, x squared equals 64. X squared equals negative 121. If I take the square root, I get x squared equals plus or minus the square root of 64. Not x squared, x equals plus or minus. And what's the square root of 64? 8.
do we have to write it like in each individual answer, like x equals -8 or x equals +8?
I'm willing to accept this.
Oh,
The alternative to this, I'm glad you actually said it. This is 8 or -8. But that works as well. There at some point in this not necessarily this lecture today. But you're gonna actually, like, if we have two different things going on, you're gonna wanna figure out what they are and separate them. As you'll see, it pops up during quadratic formula. If I do the same thing over here, take the square root of both sides, have x equals the plus or minus the square root of negative 121. Anyone know what that is? It's 11, but it's negative. So what's the square root of a negative give me? I. Plus or minus 11i. Which is x equals 11i or negative 11i. Either of those work. Now, you may not start in that form. This form could have easily started as x squared minus 64 equals 0, or x squared plus 121 equals 0. You could even do factoring on these. And zero product rule is an option here. You would have x minus 8, x plus 8 here. The easiest way to do this is recognize this as the difference of squares. And if it's not a difference, write it as a difference. I would rewrite x squared plus 121 as x squared minus negative 121 equals 0. So if I want to do a minus b and a plus b equals 0, a squared has to equal x squared, and b squared has to equal negative 121. And you can still get x minus 11i and x plus 11i, but it's a lot harder to get those imaginary ones by factoring. Until you're fluent, like you're good. All right, you guys ready? That's easy mode shit.
Oh no, wait. Sorry.
Oh, Lydia asked me
You
in an email when our exam is gonna be. It was gonna be Monday, October 16th. But none of you fools watched the goddamn video except Eric. So like, I could make it that Wednesday, but that's crappy, lecturing and then 2 days later a test. I want you guys to at least have the weekend. So our test will be Monday, October 23rd. I need to revise the syllabus to say that.
October what, sorry?
The test midterm is gonna be Monday, October 23rd.
23rd, okay. I'm done, thank you.
Okay. So let's kick it up a notch. Now, I could multiply that out and try factoring. I would get x squared minus 16x plus 64 equals 24. X squared minus 16x plus 40 equals 0. And I could try to find what works. If anything. But that's the long one. I've already got a square on one side. Let's take advantage of it. Let's take the square root. This thing is squared, so after I take the square root, the left side is just x minus 8. The right side is plus or minus the square root of 24. And so I could add 8 to both sides. I get x equals 8 plus or minus square root of 24. 24 is 6 times 4. So I could do square root of 24 is square root of 6 times square root of 4. I could rewrite this as 8 plus or minus 2 square root of 6. That is the valid answer. It's also okay to say 8 plus 2 root 6. And or x equals 8 minus 2 root 6. That approach also works. You need to remember what plus or minus means there, though. So it's probably better in your interest to write the right side each time, although I will take the left. All right, you guys ready for the next topic?
Yeah.
I'm gonna jump to quadratic formula before I go back to completing the square. If ax squared plus bx plus c equals 0 and a does not equal 0, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You do really dare to challenge the great and powerful odds?
I remember this off a really stupid.
I'm
jingle.
absolutely certain it's b squared. I am not uncertain.
I remember this off a really dumb jingle that one of my teachers taught.
Let's hear it.
No, hell no.
Let's hear it.
You brought it up with you.
Yeah, now you are being a chicken.
No, that one sounds really dumb saying.
How about I say the dumb jingle I know and see if it sounds just as dumb?
Go ahead.
So there's this negative boy and he couldn't decide if he wanted to go to this radical party.
Okay, that's one of them, yeah. That's not a jingle, that's a story.
There's the door, if you don't like my fucking story. There's a negative boy and he's undecided if he wanted to go to this radical party. He was such a fucking square. He ended up missing out on 4 awesome chicks that he could have hung out with. The party was over at 2 a.m. There's a negative boy. He was indecisive. The radical party. He was such a square. He missed out or lost meeting 4 awesome chicks. Party was over at 2 a.m.
I remember that story, but that's not a jingle.
So what's the jingle?
So,
I
yeah.
said a stupid story.
No, I said a stupid jingle.
I give a stupid, I know what you said. It's not helpful to your peers if they don't know it.
Just fucking say.
Why don't you come whisper it in my ear?
I'll tell you after class, you can tell it the next class.
Why don't you say it right now?
Sounds great.
You smell that, right?
Louis, shut up.
Can you guys spell it over Zoom? Cowardice. He's yelling.
No.
Be different if you were answering the question. I said I wouldn't do that. But if you're gonna bring up a fucking jingle and then not do it. Yeah. You set yourself up. Alright. What's that equation we were doing? 8x squared minus 10x minus 3 equals 0. A here is the number in front of the x squared. B is the number in front of the x. And C is the constant. I am gonna write that with parentheses for every missing letter. Alright, let's start plugging in what we got. B is the goes in the first two parentheses on top. I got a -10. That negative is different than the negative that's already associated with the B. That -10, the negative is getting squared inside the radical. A was 8 and it goes there and there. C was -3. This looks like this is gonna get ugly. -10 is +10. Plus or minus. The bottom, 2 times 8 is 16. I've got inside the radical, -10 squared is 100. And I've got -4 times 8 times -3. Which is -32 times -3. Which is +96. So plus 96. (196) is divisible by 4. 196 might be a perfect square. I got the feeling it is. But let me keep writing it, because if you don't recognize it as a perfect square, you're definitely not going to on the test, so we should know how to go forward from here. Calculator would help you right away, but this is 4 times, I think 49. And we can split that into square root of 4 times square root of 49. So x equals 10 plus or minus 2 times 7 over 16. So 10 plus or minus 14 over 16. That does simplify a little bit, we can at least reduce it. Divide out a 2 on each of them. 5 plus or minus 7 over 8. And then this is where we would want to break it into 2 different answers. We don't want to leave it as 2 different answers here. So we're gonna fork that into 5 plus 7 over 8, or x equals 5 minus 7 over 8. Five plus 7 is 12. So we have 12 over 8, which simplifies to 3 halves. And this is negative 2 over 8, which simplifies to negative 1/4. And those should be the answers we got before. Bye, Jimmy. You know, I used to know a Jimmy before, but it's gone, I lost it. Too much drugs in my life or something, I don't know. Alright, so. We had x equals negative b plus or minus square root of b squared minus 4ac. All over 2a. B squared minus 4ac is called the discriminant. It sounds like discriminate, but it's not. It's discriminant. Which leads to some interesting results. If b squared minus 4ac is greater than 0, x equals negative b plus or minus the square root of a positive number over 2a, which leads to 2 real solutions. You'll find solutions are also called roots. I don't know why they call it roots. They don't use the word root when it's a linear equation. But anything that's a quadratic or higher, they call them roots. You guys see that? If in here is positive, we're taking the square root of a positive number. So we're gonna, it could be a shitty number, it could be like a decimal. But we're gonna have a real number plus or minus another real number, all over a real number. If b squared minus 4ac is negative, x equals negative b plus or minus square root of a negative number over 2a. This gives us 2 complex solutions. Or 2 complex roots.
Sorry, I just have a question with that.
Okay,
The first one you wrote the x equal minus b plus minus in the one is inside like the root.
POS for
it is pass. What is that? PAS?
POS for positive.
Oh, POS. Oh yeah.
Yeah,
And the one that it is below what it
is
says
NEG for negative.
and what, sorry? Oh, negative. Oh, okay. Okay. Oh, now it's more clear. It was like blurry.
Sorry,
No, no, not now. It seems clear. It was more blurry. Yeah, right now.
yeah, it's okay. Cause we'll have the square root of a negative number, that's gonna give us an I. And since there's an I, there's imaginary, the B is real, real and imaginary gives us complex numbers. Finally, if the discriminant equals 0. Then x equals negative b plus or minus the square root of 0 over 2a, which is just negative b over 2a. Only one real root.
Plus,
That shit off. Alright. Let me give you guys one to do. Give it a try. Remember, it's gotta equal 0, so you make it equal to 0 first. Alright. So A equals 1, B equals 6, and C equals -3. Negative B is -6 plus or minus the square root. The B squared is 6 squared. -4 times A times C. All over 2A. Oh, x equals -6. Plus or minus the square root of 36. Plus 12 over 2. So that's square root of 48. 48 is 4 times 12 or 16 times 3. I like 16 times 3. So 4 root 3. This is each one divided by that. So -6 divided by 2 is -3. And 4 divided by 2 is 2. -3 plus or minus 2 root 3.
You said, what, 12 and 4 over 2?
12 and 4 works as well. But 12 factors more gives you 4 and 3. Like, if you had left it stopped at 2 root 12. Instead of 4 root 3. Not small enough yet, you hadn't gone. You hadn't factored it up yet. You could have done this like this though, square root of 4, square root of 3, square root of 4. You would have gotten 2 and 2 and then square root of 3. Let's take a 5-minute break before we start completing this square. Alright, so they developed this method completing the this whole quadratic formula was developed. Was developed using a method called completing the square. This is really useful for graphing. So it's got a purpose. Okay. Let's show you how it works. Let's show you how they got the quadratic formula. So step 1. We don't want A in front, so divide by A. A in front is ugly. It doesn't work for the solution. So B divided by A, we don't know what that B is, we can't like simplify it. And we've got C divided by A there. 0 divided by A is still 0, that's convenient. Now, you wouldn't have the equal 0 part in the graphing. So we'll do more with the graphing approach later. But we are gonna take advantage of the equal 0 part right now. Let's get x's by themselves. So I'm gonna subtract C over A to the other side. And I have x squared plus B over A x equals negative C over A. Now, where they got the idea of this next part? Let me just show you something real quick down here, it's unrelated. If I had x squared minus 6x plus 9 equals 0, when I factor this is x minus 3 times x minus 3, which is x minus 3 squared. This thing right here is half of that. That's the motivation for this next part. What they want to do is they want to write this as x plus, and the plus comes from this sign right there, something squared. Well, to do that, they're going to take this and it's divided by 2. So B over A divided by 2 is the same thing as B over A times 1 over 2. So B over 2A. On the left side, I have added B over 2A squared, which means I need to add B over 2A squared on the other side. And if I do that, I now have B squared over 4A, if I distribute the square, minus C over A. 4A squared. Gotta fix that shit. So this thing right there is B squared on top, 2A squared on bottom, and each of those gets squared to get a 4A squared. I'm gonna get a common denominator on the right side by multiplying this thing by 4A over 4A. If I do, I have x plus b over 2A squared equals, and now that I have a common denominator, I can put it together. B squared minus C times 4A, if I put it in alphabetical order, 4AC. So the big step going from 2 to 2 down to here, 3 is divide the coefficient of x by 2. And add the square to both sides. That's what I did there. And now solve for x. With the square root. If I take the square root of both sides here. The left side is x plus b over 2a. The right side is plus or minus the square root of b squared minus 4ac all over the square root of 4a squared. That bottom is just 2a. And if I subtract negative b over 2a from both sides, we get our glorious negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm gonna do, there's two examples, but I'm gonna do one, because we've already used up like an hour and we need to get some stuff done. I'm gonna do the hard one.
Wait, just let me take a picture. Sorry. A minute. I'm done.
Anyone else need it longer? Alright, so let's go with. Fuck it. What do we have? 8x squared minus 10x minus 3. First thing I'm gonna do is divide everything by 8. And I get x squared minus. I can write 10 over 8 is the same thing as 5 over 4 if I reduce. So I can write this as minus 5 over 4x minus 3/8. And I'm gonna add that 3/8 to the other side. Well, I'll add 3/8 to both sides, it makes it positive on the side, basically. So I wanna have x minus something squared. Where the minus comes from that. What I'm gonna do is I'm gonna take this and multiply it by 1/2. 1/2 times 5/4 is 5/8. I need to add 5 over 8 squared to this side to make that happen. Which means I need to add 5 over 8 squared to this side to make it happen over here. So I'm gonna clean this up a little bit while I got a little bit of room. 5 squared is 25 and 8 squared is 64. And I can multiply that 3 over 8 times 8 over 8. If I do, I get 24 over 64 plus 25 over 64. When I add those together, I get 49 over 64 on the right side. Now we take the square root. I get x minus 5/8 equals plus or minus square root of 49 over the square root of 64. Which is plus or minus 7/8. I add 5/8 to both sides. X equals 5 plus or minus 7/8. Which, if you look back in your notes, is what we had when we did quadratic formula. And this ended up giving us 3/2 or -1/4. Was that fun? This is the most sucky way of doing it, I know. Later on, it will be handy for graphing. And hopefully we're not doing it on ones that are shitty to graph. Let you finish writing that, and then we'll do a couple more things in this section, then we'll like get 1.6 started. I don't know how I did 1.5 and 1.6 in like an hour and 45 minutes in the other videos. I think I just talk slower with you guys. Just cause like, I don't know, Luis just looks like he's not getting it, and I gotta fucking talk slower for him. I'm being more thorough, that's all. Alright. So, what about solving a cubic? A cubic, yeah. Hair on your chest. X cubed minus 125 equals 0. So this is x cubed minus 5 cubed. And we had a formula for a cubed minus b cubed. It was a minus b times a squared plus ab plus b squared. We're going to apply that here where a equals x, b equals 5. So x minus 5 times x squared plus 5x plus 25 equals 0. I know what the fuck I'm yawning for. I got a lot of rest in the last 2 days. Like listening to an audiobook with one eye closed quickly turns to napping. I got a couple naps in yesterday and on Monday. All right, so I got two things multiplied together. that equals 0. So 0 product rule. X minus 5 equals 0. Or x squared plus 5x plus 25 equals 0. I solved this one pretty easily. Add 5 to both sides, I get x equals 5. Here, I need to do a quadratic equation. Got -5 plus or minus square root of 5 squared minus 4 times 1 times 25 all over 2 times 1. So I've got -5/2 plus minus 1/2 square root of 25 minus 100. Which is -75. Which is 25 times 3 times -1. So when I'm taking the square root of that, I get 5 on the outside, the square root of -1 is an I, and I still got the square root of 3. And I still have that x equals 5. You like that, Jimmy?
Yeah. It's all right.
How many answers do I have here? I heard an answer. 3.
Why 3?
X equals 5. X equals -5/2 plus 1/2 times 5i minus or 5i√3. And or x equals -5/2 minus 1/2 times 5i√3. 3 different answers. And I start off with the cubic. How many answers did we have when we had the quadratic? 2. Is there a fucking pattern here? We will cover this more later. But as a little quick blurb, polynomial with x to the n has at most n unique complex solutions. That at most is important. As you'll see when we're like doing stuff later on. It could be like x to the 5th power and we only have like 3. But it means one of them is counted as a repeated root. That's just something fun to notice. For quadratics and cubics, you're gonna have 2 and 3 every time. The homework will throw some shit at you like this too, where they don't give you anything but letters. You know how the homework does it. Homer likes to do some shit like this. And solve for P. Or Y. Solve for Y. So I have a Y squared and a Y. This could be an AY squared plus BY plus C equals 0. We can make this a quadratic. It's not gonna be pretty. It's gonna be ugly as fuck. Like turn out the lights ugly. I'm gonna start off by subtracting the 3p over here to the left side. And I'm not gonna try to factor because I don't know what anything is. I'm gonna use the quadratic formula. So I've got y equals negative b plus or minus square root of b squared minus 4ac over 2a. And what that means here. God damn it, Jimmy. Stop that shit. I don't know that I did. I'm not certain that you didn't yawn earlier. And then I fucking didn't even notice it and yawned. And I'm being blamed for your transgressions. That sounds like some Jimmy shit to do. Alright, so I'm plugging shit in. I don't have to like it. But I should try to clean it up. At least make it presentable. Negative n is positive n. And then I've got plus or minus. Negative n squared is n squared. And then I've got minus 4 times 2 times negative 3, which is positive 24. And I still got an m and a p there. All over 4m. It doesn't get much prettier than that. Isn't that beautiful? Should get that shit tattooed on the fucking forearm.
And take out the n since it's in squared. Then I
It's gotta come out of both with the plus sign there.
get back to this before.
I can factor the 24, but it doesn't have an n in it. Like whatever I take out, it's gotta come out of both things.
So in this one, only the y's are seen as the variable.
Yeah, and it was
Oh.
specified as such at the beginning.
Okay.
Solve for y.
Oh, it is like this, for example, and if it wasn't an I and Y and it wasn't another like variable, like if you specify, we have to take that in like as the variable, right?
Yeah, if I say solve for something, it means treat that as a variable.
We will have that in the test or in this course.
It's gonna be in the homework. I don't know, I won't put anything like this on the test. Like the shit on the test will have numbers.
Like the test, because sometimes like the homework. No, just keep on my. I ask you at the end of the class.
So the homework is gonna be harder than the exam. There's a reason for that. Get the
Okay,
hard shit out of the way,
that-
so you learn the skills when you've got time to make mistakes and do it. Test on stuff, I'll still test you on the methods, but I'll have numbers for some shit like this rather than
Okay,
like
that's the
M's and
answer
N's
to my
and
question.
P's is bullshit.
That's the answer to my question.
Okay. So, 1.5 is on modeling. I'm gonna make a video of that for you guys. And I'll like load it up, it'll be shorter. I wanna get started on 1.6. You're not tested on, well. You're not tested on starting with the model. You'll see with the modeling. 1.6 is like it's other types of equations. That's what we're going for. One example is rational equations. I guess this is 1.6a because we're not gonna finish today. Two x minus 3 over 2 plus 5x over x plus 1 equals 0. Or equal, no, not 0, x. Let's make it equal x. When you have a rational equations, what you should start off do is make a note of bad value. Of answers that won't work. Answers that don't work for rational equations. Make the denominator equal to 0. X plus 1 cannot equal 0. So x cannot equal -1. If we get that answer, we have to reject it. Step 2. What does Hefe say to fractions? Fuck fractions. How do we get rid of fractions? Multiply by what? Effectively. We want to multiply by the common denominator, which would be the reciprocals of the bottom. I'm going to multiply everything by 2 and x plus 1. For the first one, the 2's cancel, and I get 2x minus 3 times 2x plus 1. For the second group, the x plus 1's cancel, and I get 2 times 5x. And on the right side, I have 2 times x plus 1. Alright, so we got a lot of work here. We gotta multiply, distribute, do all that good stuff. I've got 4x squared plus 2x minus 6x minus 3 plus 10x equals 2x squared plus 2x. So C is solve for x. Alright, I got a lot of shit going on the left, let's clean it up before I continue. I've got 2x, negative 6x, and 10x. So 2 plus 10 is 12, minus 6 gives me positive 6x left. And I still have minus 3 equals 2x squared plus 2x. I will subtract 2x squared and 2x from both sides. Because I want to get, since I have an x squared, I want to get everything on the same side. I don't think that factors, did I fuck up something?
Shouldn't it be x plus one instead of two x plus one? On the green, it's just two x minus three and six plus
I did fuck up something. That should, yeah. Wait, it should have just been x plus 1. Fuck, that changes shit. This is 2x squared, oh, fuck it, scrap that. We'll continue with that correction. I got 2x squared plus 2x minus 3x minus 3. You're right, I didn't actually cancel out the fucking 2. I just kind of moved it inside and said, fuck it, it's here. And I moved it inside wrong. That's just fucking, I pulled a Jimmy.
Yeah, that's awesome.
Not you, it's a different Jimmy. Honestly, it is. There's a Jimmy we played D&D with that he would fucking just like delay the game, ask so many fucking stupid questions. It got so bad that I started making fun of him. When I cast my spell, does it smell like oranges? Does it make me want to die in a ditch? I said a bunch of fun shit, it was great. Alright, so we'll clean up here. I got 9x minus 3 equals. Well, this is gonna be good, because when I subtract the 2x squared here, shit gets nicer. I just get 7x minus 3 equals 0. Assuming I didn't fuck it up again. Add 3 to both sides and divide by 7. And so now the final step is check against the bad juju answers. My bad juju answer was x equals -1. That doesn't equal -1, so that's valid.
Crazy.
You know, that's called the Chipotle protocol. Yeah, I told you, did I tell you guys about the Chipotle protocol?
Yeah. Better thinking of semester.
Yeah. You guys just unfortunately got it without earning it. That's a bad beat. I didn't even have Chipotle. You just never know what's gonna trigger it. Alright, let's take a look at another one. X over x plus 5. Plus 5 over x minus 5. Equals 50 over x squared minus 25.
Moving down, they're off the grade like that.
Alright, fine, you can't fucking just write down what I'm saying out loud. It's great, Jimmy's character was killed in such a glorious manner. That we know he fucking quit playing D&D. Cause of it. He fucking was playing, he was getting along just fine. And then his character died in such a glorious manner. So it was like near the end of the night, I really didn't want it to end like this, this was gonna be my last night. Sure it was, Jimmy. Different Jimmy,
Yes. What's the ending? Dragons one.
Dungeons and Dragons,
Done.
like the movie that just came out recently.
Yeah.
Alright, so if I factor x squared minus 25, this right side here is really x minus 5 times x plus 5. So that's a difference of squares. So if I get the common denominator to multiply by is just x plus 5 from the first one, x minus 5 from the second one. And this third one already has those, so I don't need more. So that's what I'm gonna do. I'm gonna like write it out a little bit better, showing a little bit more room, so you can see it. And we're doing x plus 5, x minus 5 on each of them. And maybe if I would have written it out like this last time, I wouldn't have fucked it up. You really do use it, we say origin all the time. I've struggled to not say that in here because I have a Jimmy in the class. And then I fucking accidentally let it out and everybody just gave up, like, ah, shit. Just put Jimmy on blast. Alright, so the x plus 5 is canceled there and I have x times x minus 5. Here, the x minus, oh, and I still, yeah, the x out front. Here I got the 5, the x minus 5's cancel and I have x plus 5. And here, both of them cancel.
My first student name.
What?
No, they can't.
I've had some changes, but I think it actually goes by Jimmy, yeah.
Yeah.
Alright. Before I continue and before I forget, let's find our bad juju numbers. Bad juju is when the common denominator equals 0. So I can do what we just got doing. We'll factor. We'll do the 0 product. And I get x equals -5 or x equals 5. Those are our bad jujus. So x cannot equal plus or minus 5. Keep that in mind. Alright, so we'll distribute. And I'm gonna subtract 50 over to this side right now, just to get it over here. So I did minus 50 at the same time. This side, those cancel. And 25 minus 50 is negative 25. So you can complete the square, or you can do factoring, or I could just say solve for, I got a square with no x's, I could just do that and take the square root. And I get x equals plus or minus the square root of 25, which is plus or minus 5. What? Why? We did just say it can equal that, didn't we? Look at that, my good Jimmy. Answering it. Rather than my bad Jimmy that plays D&D. So neither of those answers work. And those were the only two we got, which means there's no solution. We have to reject that. Can't do that. Put a. Any questions? All right, rather than starting with radicals, I'm gonna skip to the good shit. Equations that in quadratic form, but not quadratic. X minus 2 to the 1/2. Minus 6 times x minus 2 to the 1/4. Plus 7 equals 0. Let's make it plus 5. Now, this looks like a serious pain in the ass. But and the way you can identify this is if this is 2 times that. So 1/2 equals 2 times 1/4. This method will apply. What I'm gonna do is I'm gonna say u equals this smaller term right here. U equals x minus 2 to the 1/4. Which means if I square it, U squared is x minus 2 to the 1/2. Following this. And I can rewrite this as u squared minus 6u plus 5 equals 0. And now it is quadratic. Doing this kind of thing shows up a lot in calculus. Maybe not so much recognizing that this is a quadratic form right here, but making this type of substitution and working with it. If I factor this, this is u minus 5 times u minus 1. So I can set each of those equal to 0. If I solve, I get u equals 5 or u equals 1. But I didn't start with u, so I'm not gonna end with u. Now we gotta go plug that shit back in. X minus 2 to the 1/4 equals 5, or x minus 2 to the 1/4 equals 1. Just like when we squared it to get rid of the square. If I raise this to the 4th power. 1/4 times 4 equals 1. And this will just be x minus 2. So I'm gonna raise that side to the 4th power as well. Now I'll do that over here, raise these to the 4th power as well. So if you have some weird exponent, the simple way to remember it is raise to the reciprocal. Reciprocal power. One-4 turns to 4/1. If I do that here, I got x minus 2 equals 5 to the 4th power, which is 625, I believe. And here, x minus 2, 1 to the 4th power, that's pretty fucking easy. Okay. And now I'll solve for x. X equals 627 or x equals 3. Any questions? We'll do a couple more examples of this and then radical ones on Monday. GTFO. Have a good weekend, guys.